Hello, my friends. Thanks for joining me this week here on Origins. My name's Don Chapman, and you know, Origins is a forum where we take the evidence of science, we use it to validate the truth of creation. Dr. Russ Humphreys is here with us today, and Dr. Humphreys is a physicist. He did his undergraduate work at Duke, and his PhD is from LSU. You worked from 1979 through 2001 at the Sandia National Laboratories, and since 2001 you've been full-time as a creation research scientist, and you're quite a gift to the Church of Jesus Christ. We're so thankful for you and for your work. Today we're getting right to the nubbins of the thing, as they say. We're going to talk about evidence for a young Earth.
Most dating methods give a young world. And I'm not going to read this whole list, but I want to convey the idea that there are hundreds of ways one could use science to get an idea of how old the Earth is. 100 at least, maybe 200 methods. And the surprising thing about this is the proportions. 90% give you a young world. 90, most. Most of the evidence. Now you see, other people think that this 10% is all they know about. That's radioisotope dating, carbon-14 dating, light from distant galaxies, and things like that. They've all heard that. That's the evidence that you find cited. But most of the evidence is in the literature, but it isn't tagged. It's in the science literature, but it's not tagged as evidence for a young world.
So let's look at some of those. Where are you going to get your evidence, sir?
I'm going to get it from an internet article that I wrote back in June 2005 at the Institute for Creation Research called Evidence for a Young World. And it's got publication and internet references on the back pages. And you find it on ICR.org. And I'm going to go through the 14 items of evidence, not all of them, but most of them, that are in here, and you can get more information from that brochure.
I'm sure many of our folks will want to go to ICR.org and follow up on that. So I'm going to ask you to go up to our board and to present some of those key points of evidence for a young Earth to us, Doctor.
The first item in the articles is that galaxies wind themselves up too fast. Now, what's a galaxy? It's an island of stars that's about 100,000 light years across, and a light year is 6 trillion miles. So it's big. And our own galaxy looks a lot like this one. This is our nearest neighbor galaxy, Andromeda, which is 2 million light years away from us.
And there's billions of stars in there. In fact, hundreds of billions of stars.
That's exactly right.
But you can see that it's not just independent stars, that there is a form to all of that.
Yes, you see these spiral structures. They're called spiral arms. They're made up of stars, and each individual star likes to rotate around the galaxy. And around the center of the galaxy, stars go very fast. They go very fast there. But way out on the edge, they go slowly, just like the planets in our solar system.
And what do you mean when you say they wind up too fast?
Well, these spiral arms are made up of individual stars, and the outer ones are going around slowly, and the inner ones are going around very fast. So this spiral structure will wind itself up, just like a clock spring. And
so over a period of billions of years, if there was such a thing, it's pulling itself in and becoming tighter.
Yes. All the nearby galaxies, including our own, are supposed to be 10 billion years old for the age of our nearby galaxies like this one, Andromeda. But the winding up occurs so fast that even if you had started with a straight bar of stars rotating at the speeds we now observe, it would only take 0.3 of a billion years to wind up to this state. Now, we don't know at what state God started the galaxies, so we don't really know their age. But they can't be much more than this old by just a straightforward view.
So they hint towards the Earth being much younger than the billions and billions we always hear, or to the galaxies being much younger than
Now, I should say that the other side has a theory. They've had a lot of theories and scrapped a lot, but the current one hasn't been scrapped yet, but it's in deep trouble because it doesn't explain detailed structure of galaxies very well. So it's sort of a hand-waving sort of theory right now. It's not in good shape.
Now, while you're talking about galaxies, there's something about magnetic fields.
Oh yes. This is recent news that distant galaxy magnetic fields are young. See, they once thought that very distant galaxies would only be partly formed and only partly wound up, and they found out that the magnetic fields in those galaxies follow those spiral arms. So this is the letter to nature: strong magnetic fields in normal galaxies, and then I'm going to translate at great distances.
Okay.
And they weren't expecting that. So I've drawn in the lines of force in yellow there. See these yellow lines?
Uh-huh.
Those are, if you took a compass needle and worked your way around the galaxy with a great deal of patience and a lot of spaceships, you would find that they follow the spiral arms. And that goes against their theory of how spiral arms might preserve themselves for billions of years, and it goes against their theories for this to occur at very great distances. So they're in deep trouble with galaxy magnetic fields and other things.
So again, magnetic fields seem to take us to less than 0.3 of a billion years.
Right. It's it's a maximum possible, and it's a lot less than the 10 billion years that the Big Bang Theory requires.
All right, while we're still in outer space, let's talk about comets.
Comets crumble too quickly. Now, a comet is what Fred Whipple called a dirty snowball. But this is something that creationists have known about for some time, so I won't spend a lot of time on it. But these dirty snowballs, when they swoop by the sun, lose that material that you see sweeping off away from them, being swept off by particles and light photons from the sun, and that material doesn't all come back.
Most of a comet is mostly chunks of ice and dirt.
Yeah, and then when it gets
well
close to the sun, it bubbles and hisses and
right.
emits gas and dust, and that streams out in a tail behind the comet and never comes back.
They burn out, don't they?
Yeah, so every time around the sun, a comet will lose maybe 5% of its material. So if they come around pretty often, they couldn't have been around very long. They're supposed to be 5 billion years old, the age of our solar system, but it looks like they could only be in the solar system less than 100,000 years at most, 10,000 years on the average. So the other side has a theory. It's called the Oort cloud. There's supposed to be a cloud of these dirty snowballs way out beyond the boundary, and it's a spherical cloud, and that cloud is supposed to feed dirty snowballs into something called the Kuiper belt. In the Kuiper belt, we have seen some large asteroid-sized chunks, but not comet-sized chunks of ice, but not very many, and it wouldn't be enough to explain things all by itself. It has to be fed by the Oort cloud. The thing is, nobody's ever seen the Oort cloud of our solar system.
In fact, don't we even have evolutionary scientists saying that they can't find an Oort cloud?
Yes, I knew one back at Louisiana State University who he wasn't a creationist, but he was very skeptical about the Oort cloud theory.
And without an Oort cloud, then comets have to be young.
Yes.
All right. Now we're going to leave outer space, and we're going to go down in the ocean.
Seafloor mud accumulates too fast. Geoscientists have figured out that we have about 20 billion tons of mud entering the ocean every year. And then we have some that gets out. And the total amount of mud in the ocean, if you took all of this mud and spread it all over the whole ocean, it would be about 400 yards thick. And then to get out this mud, we have plate tectonic subduction. That's the only way known to get much out. These plates of gigantic thick slabs of rock are sliding under the continents slowly at about the same speed that your fingernail grows. Not very fast. But if it dragged all of this 400 meters of mud underneath, then it would get rid of about 1 billion tons per year. Maybe 2 billion if you wanted to be real optimistic. But that leaves 18 or 19 billion tons unaccounted for. So we have, let's say, 18 or more billion tons per year, just accumulating year after year. And it wouldn't take too long, from a geoscientist's point of view, to get this amount of mud.
So if you measure the mud that was there, how many years would we come up with?
At most, 12 million years.
Yeah.
Now, the thing is, we have this thing called the Genesis flood to reckon with. And so in 1 year, you could easily dump almost all of that 400 yards of mud in a short time between 4,000 and 5,000 years ago. This process of mud entering the ocean is supposed to have been going on for 3 billion, billion with a B, years, not 12 million.
So, and if that were true, there would be a whole lot more mud by now.
That's exactly right. The oceans would be choked with mud.
Almost, yeah, without oceans. All right. That's an incredible argument. And then also, while we're in the ocean, not only the mud, but the salt is a problem to the old Earth people.
That's exactly right. The sea isn't salty enough to suit the taste of an evolutionist. Dr. Steve Austin and I wrote a paper on this. We tabulated, and not only we, but geoscientists in general for 80 years have been tabulating this. There's about 450 million tons per year of sodium going into the ocean.
It isn't really being dumped out of a salt shaker.
No.
Yeah.
It's being dumped by those same rivers that dumped mud.
Okay.
And other sources. There's other ways that sodium can get into the ocean. The mid-ocean, mid-sea springs, for example.
Okay.
But getting out of the ocean, geoscientists have only been able to find at most 120 million tons instead of 450. Getting out, like if you smelled salt spray at the beach, that's some sodium getting out of the ocean, being blown out as crystals. So that sets a limit on how old the ocean can be also. Now the maximum possible age, if it started with no salt to begin with, and if the rates were the best possible rates that the evolutionists conjecture, then the maximum age would be 62 million years. The Genesis flood could easily account for most of the sodium that's in the ocean today. So.
All right. Now, you're also talking about the Earth's magnetic field.
Now, the Earth's magnetic field is something people don't think about very much, but everyone's had a compass at one time or another. And the Earth's magnetic field is what makes that compass needle point north.
Right.
And the point of this is that the Earth's magnetic field is losing energy too fast to be very old. Now, what do I mean by energy? Well, the source of the Earth's magnetic field is an electric current that goes around westward in the Earth's metallic molten core. And it's an electric conductor, but the electric conductor has resistance, and that wears down the current year by year. So it's a bit like a flywheel slowly slowing down due to friction. And that current is the source of energy in the Earth's magnetic field, and it's losing that energy much too fast. According to the latest numbers for about the last 30 years, the Earth's magnetic field, all of it, is losing about half of its energy every 1,400 years. In other words, you add up all the parts of the different parts of the Earth's magnetic field, every 1,400 years it's losing half its energy. So it couldn't have been losing half its energy for too long. But there's another factor, and that is during the Genesis flood, it lost energy faster than this rate during magnetic reversals. The Earth's magnetic field actually turned itself around from north to south and north to south every couple of days during the Genesis flood, according to the evidence that we have. And the only theory for this, for such rapid reversals, is a creationist one. It's mine. And that says that we would lose energy even faster. So you add all these things up and you work yourself back to the largest electric current that we could have in the Earth's core without having too many problems, and you get a maximum age of about 20,000 years. Again, if you account for this loss during the Genesis flood of energy, then that age could easily be 6,000 years.
So we're down to thousands, not billions.
Exactly.
Again.
Now, the evolutionists do have a theory. It's, again, sort of a hand-waving theory that says that something in the Earth's core would try to maintain this current over billions of years. But again, that theory doesn't work very well.
There's not really any evidence for it.
Yeah. Now, in support of this young Earth point of view, Mercury's magnetic field looks like it's young. Now, here's a plot of time along the bottom. This is the year. This is 4000 BC, and here's today. And magnetic moment. That's just a measure of how strong the source of a magnetic field is. And this is a very compressed scale, and you don't need to know the numbers. But I have a theory for the created value of the Earth's magnetic field. And then we had, in 1975, the first of these little dots. That was 1975. There was a measurement by a satellite called Mariner 10 of Mercury's magnetic field, and it was already down to here. So my theory would say that the field decayed steadily on a straight line on this kind of graph. Very rapid decay. It's 3 times faster than the Earth's field is decaying. In another couple of decades after 1975, my theory said, we should be able to detect a decrease of that field. And we found it. Here's the Mariner 1975 number, and then Messenger, the Messenger spacecraft, in 2008 measured a lower magnetic field, very significantly lower. And it's within the bounds of my prediction, or it might even be a little lower. But that's very hard for the other side to explain.
That's fascinating. And so both the magnetic field of the Earth and of Mercury have indicated that they just can't be that old. Is that right?
Right. And the same theory works just as well in other parts of the solar system, too. So we think we've got a pretty good explanation of magnetic fields in the solar system, how they started, what happened to them, and how they got to where they are today. And that theory has made predictions.
Dr. Humphreys, the overwhelming preponderance of this evidence piling up one upon the other is so convincing. Each one of them is interesting by themselves, but when you start to add them up, they become very significant. And we have more evidence that you'll want to hear. Don't you go away. We'll be right back.
Creation versus evolution. You weigh the evidence. The bird feather. It couldn't just happen. For their weight, feathers are stronger than any man-made structures. The design and functions of a feather are even more astounding. Evolutionists claim that reptile scales evolved into feathers. Feathers have a much more complex DNA structure than reptile scales. There is virtually no similarity between the two, nor is there any fossil evidence showing the transition from scale to feather. So how can evolutionists claim this really happened? Today's guest on Origins, Dr. Russell Humphreys, is a physicist and speaker with Creation Ministries International. Russ did scientific research for 22 years at Sandia National Laboratories and has published some 20 papers in secular scientific journals. He is the author of Starlight in Time, where he proposes a model for a young universe. Book orders are being taken at 800-616-1264. Russ has also been involved with the RATE Project, which has produced breakthroughs on the subject of radiometric dating. Dr. Humphreys can be reached at Creation Ministries International, P.O. Box 350, Atlanta, Georgia 30127, or visit the website www.creation.com.
We are back with Dr. Russ Humphreys, and we are talking about evidence for a young Earth. Dr. Humphreys, you've given us some amazing evidence, both from science and from the sea and from the magnetic field of the Earth and of Mercury, but you have some other evidence you want to show us as well.
Yeah, this is more fun evidence, more things that people can grab hold of right away, and that is that biological material decays too fast. This has been happening the last 10 years. These are only samples, but mitochondrial Eve was supposed to be 200,000 years old, but as they actually started at mutation rates to figure out how long ago this mother of all living things was, they got as low as 6,000 years, and that was actually published.
6,000 years.
So mitochondrial Eve is pretty young. DNA in amber. DNA, that's a model of a DNA molecule right there. DNA is supposed to decay within 10,000 years. The experts on DNA say even if you preserve it in the best possible conditions, it will fall apart on its own within 10,000 years or less. And yet, in amber, that's supposed to be 135 million years old, they can reconstruct the DNA of insects. Interesting. Lots of things. So that's less than 10,000. Permian bacteria. Permian era was supposed to be 250 million years ago, and yet they have revived bacteria from formations that are supposed to be that old. Again, the DNA, their own DNA should have fallen apart by that or been destroyed by environmental radiation. And Neanderthals, they've dated Neanderthals. By the way, they're ordinary humans, just another branch of the human race, and they got some blood that was allegedly 40,000 years, and they reconstructed large parts of his DNA. And so Neanderthals were probably here a lot less.
Less than 10,000
Less than 10,000. Dino blood cells. They found at blood cells from a T-Rex a few years ago. You may have read about that. Supposed to be 70 million years old, actually less than 10,000 probably.
I think that's amazing evidence.
Yeah. This is real simple. Not enough Stone Age graves. Now the evolutionary point of view, this is time along the bottom here. Mm-hmm. And this is the evolutionary view of the total population of the human race. About 1 million people it would be limited at by hunting and gathering. You just can't get more than so much food per acre by hunting and gathering. And then at the end of that period of limited food, then suddenly some bright cave guy is supposed to have discovered farming. I don't know why it would take him nearly 200,000 years, but anyhow, then the population took off. But if you ask yourself how many people were alive during that 200,000 years and were buried, you get about 8 billion people. That's 2 billion more than are on the earth now. So you should be able to go to your backyard and find a Neanderthal or Cro-Magnon grave, and you can't.
I haven't found any.
So it's much more consistent with a short Stone Age after Babel, which was after the flood, for a few hundred years in most places. So only thousands of those graves exist, and it's consistent with a short time, not a long. Now, this is one that's obvious. Written history is too short. If you just plot the number of published documents that we can find, now the published documents are in the billions. Around the time of Christ, the number that were around couldn't be more than millions. And back around the time of Abraham, we're down to thousands, like the Egyptian hieroglyphics. And somewhere we get back to Noah's diary, and that period of time is small. It's only 5,000 years. And so, you know, what about the other 200,000 years? What were we doing then? We were supposed to be pretty smart.
Wouldn't they say that before that time man couldn't write?
Yes, but that's kind of hard to imagine because Neanderthal and Cro-Magnon men actually seem to have been smarter than us to survive in an ice age. Most of us would probably not survive, so they were smarter than us. And they used cave paintings and inscribed on bone the phases of the moon. Why not use the same skills to write history?
So when you add all this up, where do you think it brings us, Dr. Humphreys?
Well, it brings us to a young world, and it brings us to the evidence for a young world being greatly outweighing the evidence for an old world. So the data for youth heavily outweighs the data for age, and the radioisotopes in the age of the Earth, I haven't talked about that, I will next time, talks about nuclear dating ages and actually deals with diamonds and takes carbon-14 right off the old side of the scale and makes it a friend of young Earth creationism. And the other old data just drop right off the scale.
So can you trust your Bible?
Yes, I think you can.
Don't just look at any one of these, but look at the concluding pile, the preponderance of evidence, and it becomes irrefutable when you add it up. You know, I still believe that it's God's view that He created this earth not long ago, and it's also His view that He created you. And that should be your worldview too, my friend. You can trust your Bible. It's been great having you with us with Dr. Humphreys, and we hope you'll join us again soon here on Origins. Until then, God bless you, my friend.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 908 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 908, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.